Alright, so here's the bioFlight wing controller for our senior design project. Basically, the idea of the bioFlight wing is to mimic a bird's flight. So when a bird stops, it doesn't, like a regular plane will just slow down its speed and kind of fall out. A bird will kind of fly in, angle its wings, and that kind of sucks its momentum away, and it stops. That's kind of the idea that we were going for here. Last semester's group had set everything up. They were the ones, the aerospace departments were the ones who actually built the wing, and the ECE department are the ones who did all of the circuitry behind it. The way they had everything set up, it was either kind of on or off. So all of the different controls were either, relaxed or sucked in all the way. The goal of our project was to make everything more of a stop anywhere you want. So we went from having a hardware box like this that just had buttons and switches and stuff on it that controlled everything to something on the computer, which is LabVIEW. The main thing there is that future semesters, if they change things around, they can fairly easily add and subtract buttons and stuff instead of having to buy a switch. The main things that we looked at controlling were the servo, which is this thing right here. The servo is what would control the wing kind of moving, the feathers of the wing moving. The way everything is hooked up, the servo kind of has trouble moving the feathers of this particular wing. The servos are being used in the future redesigns of the wing part, so we focus more on controlling the servo, not necessarily what the servo was moving. So I guess I'll just give you a little demo here. The wing is on, and so now as I click up and down on the servo button on the computer, you'll be able to see the servo kind of moving. You might need to come across. So the servo is this white piece right here, and as I click up and down on the computer, it moves back and forth. The other big thing that we were looking at controlling was the SMA groups. The SMAs are actually behind the wing. They're what control how much the wing gets sucked in and let go. The SMAs work, SMA stands for shape metal alloy. The way it works is you heat them up and they'll shrink. So we use electrical current to make the heat, and the heat makes them shrink. The thing that we also needed to put in was a position sensor, so we needed to know where the flap of the wing was, and if it was too open, we would turn on the current, and that would make the SMA shrink, and if it was too closed, we would turn off the current, and that would make the SMA relax. The difference between each state is really not much. It's hard to see, so I'm not sure if the camera will be able to get it exactly right, but we'll give it a shot here, I guess. We'll probably want to aim it straight down so that they kind of have the lines as a reference. Ready?
You know all these tone ranges.
Well, alright, here we go.
Okay.
There we go. So it's hard to see. Sorry, I can't. Alright, that's about it.